Hello, in this video we will use array formula to generate the dataset of normal distribution, Gauss function, and norms inverse. So we have a dataset here of x from -2 to +2. The norm distribution function this function returns the value of the normal cumulative distribution function because the value here is 1. For a specified value, which x, where the mean is 0, and there's for one standard deviation. So this is 1. So the last value means 1 means it's a cumulative distribution function. The Gauss function returns the probability that a random variable drawn from a normal distribution will be between the mean and the standard deviations. So in this case, we add zero point 0.5. So, and the norm's inverse returns the value of the inverse standard normal distribution function for values of x. So first we generate the normal distribution, the cumulative distribution function, which is array formula, norm test of the x values. Our mean will be 0 and 1 standard deviation. And we choose 1 because it is a normal cumulative distribution function. So we have here the trend line in polynomial regression to degree 3. So our B0 is 0.5, B1 is 0.372, and our B2 is 3.94 times 10 to the minus negative 22. So this is 0, actually 0. And this is minus 0.0338, that's our B3. So that's a value for our B3 because this is a third degree polynomial regression. Next, we generate the Gauss function. In this case, we enter the Gauss function first, array formula, Gauss of the x values. To make this the same as the normal distribution, we just add 0.5 to the array formula. So that's 0.5 plus. Now they have the exact same value. We can get the value of x if we're given the value of y using the norm's inverse function, which returns the value of inverse standard normal distribution function for a specified value of x. So we use the norms in array formula, norms in of this value. And the values of x matches to our x values. So you'll notice the regression coefficients of NORMDIST and zero point 0.5 plus Gauss are the same.